wishes to everyone present here. We are from Coimbatore Institute of Technology, belongs to the Department of Artificial Intelligence and Machine Learning, to present our project about color deduction using machine learning unsupervised algorithm. And here is myself, Ilakiya, and Shruti, and our beloved guide, Mrs. Devrani. Let's get into our project. Hope you are all very much interested to know about it. Artificial intelligence is demonstrated by machines in contrast to the natural intelligence displayed by living beings. We will be working with colors and you will get to know about many concepts throughout this project. Color detection is necessary to recognize objects. It is also used as a tool in various image editing and drawing apps. Color deduction is the process of detecting the name of any color. Simple, isn't it? Well, this is for humans, it is just a simple task, but for computers, it is not at all. Human eyes and brains work together to translate light into colors. Light receptors that are present in our eyes transmit the signal to the brain. Our brain then recognizes that color. We will be using somewhat same strategy in our project to get the names. Before starting with this Python project, OpenCV, NumPy, Pandas are the necessary packages that we are going to use in this project. Colors are made up of primarily three colors, that is red, green and blue. In computers, we define each color value with a range of 0 to 225. There are approximately 16.5 million different ways to represent a color. In our dataset, we need to map each color values with their corresponding names. CSV file includes 865 color names along with their RGB and HEX values. The goal is to partition n data points into k clusters. Each of n data points will be assigned to cluster with the nearest mean. The mean of each cluster is called the centroid or center. The thing which is you are seeing in the screen is the data set which we have used in our project. It has different columns. This the HEX value of the colors and their names, which we used in our project to get the colors from the picture. Overall, applying k-means, we have used two algorithms in our project, which is k-means clustering. Overall, applying k-means yields k separate clusters of the original kn data points. N data points inside a particular cluster considered to be more similar to each other than points belong to a cluster. In our case, we will be clustering pixel intensities of the RGB image. Given m into n size matrix image with us given on each consisting of three components, that is red, green and blue. We will treat these m into n pixels as our data points and cluster them using k-means. The result of this deduction depends on the threshold values that have been set for the images. The major problem with the threshold is that considers only intensity values of pixels. So we are using that intensity values, and that does not take into consideration and relationship between them. The thing what I have explained for a minute is the procedure what we have to follow for using the algorithm to deduct the colors. The thing what you are seeing in this screen is what the exploratory data analysis that we have did with our data set. This is the first part of a project, which is if you display an image and made a click on it, it will give you the original mixture of the colors, which means if you click it and it show you what is the mixture of pink, which is how many red, how many percentage of blue, and how many percentage of green. It will show. And now you are seeing the two images, right? Which is one part is RGB image, and the next and the thing which is in the right side is GBR image. Because OpenCV does not process the procedure in RGB format, so it will convert it into the format which is compatible for that. So only we have converted it into BGR format. Hope you are all have a clear gray. The gray part of the image is also very sustainable for the OpenSea to work with. Now have clicked the pink color image. So it is showing how the red, the 240 percentage of red is in pink, and 191 percentage of green is in pink, and blue 213 percentage of blue is in pink. And the right side part of the images, I am clicking orange color, and you are seeing how much. And this is the main part is clusters. You can even cluster the images how to n number of times. In the right side I have clustered into two, so you are seeing in two shades. And here I have clustered into 6 times, so you are seeing the 6 shades of the image. So this is the first part of a project. The next part of the project will be discussed by who is the co-author of this project. So I over to Shruti. Shruti, now you can start the presentation.
Ilakiya, am I audible? Ilakiya?
Yes, Shruti, you are audible. You can continue now.
Okay.
Shruti, you are audible now. You can continue.
Okay. So now we are the coding platforms we have used is Spider and Jupyter. The next is the model 2 is HSV color space model. HSV is a cylindrical color model that remaps the RGB primary colors into dimensions that are easier for humans to understand. 0-degree hue results in red, 120-degree results in green, and 240-degree results in blue. The detection of colors. Hue. In HSV, hue represents color. In this model, hue is an angle from 0-degree to 360-degree. Saturation indicates the range of gray in the color space. It ranges from 0 to 100. When the value is 0, the color is gray, and when the value is 1, the color is a primary color. A faded color is due to the lower saturation level, which means the color contains more gray. Value is the brightness of the color and varies with color saturation. It ranges from 0 to 100%. When the value is 0, the color space will totally be black. With the increase in the color value, the color space brightens up the shows and various colors. These are some of the applications of HSV model. The HSV color space is widely used to generate highly quality computer graphics, and HSV color wheel is used to select the desired color. The user can select the particular color needed from the picture from the color wheel. It gives the color according to the human perception. So hope you all can see the screen. These are the screenshots of the working model 2, which I will be demonstrating at the end. Next slide. This is the model building 2. These are the demonstration of the model 2. This is how the model will look. Now let's see about the comparison between the model 1, which is K-means clustering, and the model 2 HSV model. K-means clustering, importing required package and load the image, whereas HSV model captures the video through the webcam. In K-means clustering, next we read the CSV file with pandas. In HSV model, we convert the image frame in BGR color space, and we read the video stream in the image frames. In K-means clustering model, we set a mouse callback event on a window, and in the HSV model, we define the range of each color and create the corresponding mask. In K-means clustering, we create the draw function, whereas in HSV model, the image frame and mask is performed to specifically detect the particular color and discard others. K-means clustering displays the image on the window, whereas HSV model create contour for the individual colors to display the detected color region. This is how the model will look. I will demonstrate our model at the end. So these are the references which we referred while doing this project. Thank you. Now I'm going to demonstrate the model which we have done. Wait a minute. Yeah. Ilakiya, is it visible? Hello? Anyone? Is it visible?
It is visible. You can proceed. Am I audible to you?
Yeah. Okay. Wait a minute.
Okay.
Okay. Now, this is the code which we have used. We have done it in the spider. Then this is the output. So this is the frame. This is the frame. So this is the frame. Now this is the red frame. In this, when we show red colored paper, the paper will alone be in the red color. Then the other image will be in all in the grayscale image. The paper alone will be displayed in the red color. Next, when we display blue frame, when we show blue paper, it will be only displayed in the blue frame and not in other frame, not in red and green frame. It will be only displayed in the blue frame. Then the other images will look it in the grayscale feature. Then the next screen will be green. When we'll move to green, when we show green paper, the green colored image will be displayed only in the green frame and not in the red or blue frame. Then the last frame is result. This result is every color will be displayed same except the white color. White color paper will be displayed in the grayscale. I'm showing white paper. It is displayed in the grayscale image, and every other colors will be displayed as it is. So this is the project we have done. That's it.
So that's it. I hope everyone enjoyed it and you get some knowledge through this. Thank you for your patient listening, and thanks everyone. Have a great day.